Okay, so probably the number one reason students struggle with fractions is because they struggle with finding the lowest common denominator. See, when you add and subtract fractions, you need to make sure that the denominators are the same. And if they are not the same, you have to go find this thing called the lowest common denominator. And it's not that difficult to find the LCD when you're dealing with basic fraction problems. I'll show you some examples here in a second. But as these denominators become more interesting, finding the LCD becomes much more difficult, and a lot of students really struggle with this, and they don't have a good sense of what the actual procedure is. Now, let's go ahead and see how well you understand fractions. We have 3 over 20 plus 1/8. Can you add these fractions without the aid of a calculator? Well, if you can, go ahead and put your answer into the comment section. I'll show you the correct answer here in just 1 second, and then of course I'm going to walk through this problem, the solution step by step, and I'm going to really teach you how to think about the LCD and actually how to calculate it irrespective of what those denominators are. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And it really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so 3 over 20 plus 1 over 8. What is the answer? Now, I'm going to say one thing here that's going to confuse some of you. You could actually do this problem without finding the LCD. Okay, now you might be saying, "What are you talking about? You're making this such a big deal here, Mr. YouTube Math Man, about the LCD." Well, you do need to know how to find the LCD, and typically this is going to be the procedure you're going to take. However, if you want to know more about fractions, I'm going to give you some additional suggestions here. There is like a little bit of a math trick or math hack that you could take to do this problem. I'll talk more about that here in a second, but that doesn't exonerate the fact that you have to understand the LCD. But let's go ahead and see if you got the right answer. So 3/20 plus 1/8, what does this equal to? Well, the correct answer is 11 over 40. All right, so how'd you do? Well, hopefully you got this right. And if that's the case, let's give you a nice little happy face, an A plus, a 100%, and multiple stars. So you can brag to your friends and family that indeed you are a certified professional expert in the area of adding fractions. Okay, now I'm going to hold off on kind of claiming that you are an expert in the LCD because, again, there is a way you can add fractions where you do not have to find the LCD. Matter of fact, I'm just going to show you that method real fast. We'll use a real easy problem here, and then that way we can just kind of get that out of the way. Okay, so let's take this simple example. If I have 1/2 plus 3/5, okay? Now, you cannot add fractions where the denominators are not the same value, okay? So these denominators are not the same, hence we would have to go find the lowest common denominator. But let's just kind of stick to this little thing that I'm talking about where, hey, if I wanted to add these fractions without the LCD, how could I do that? Well, this I'm kind of putting the best part of this video up front. So here is an absolute great math trick, a math hack, whatever you want to call it. I call it the bow tie method. Here's how it works, okay? So you're going to take this denominator, it has to be in this very specific pattern, okay? So if you do it outside of this pattern, then it's going to be wrong, all right? So you're going to take this denominator, this bottom right, this 5, you're going to multiply across that way. So 5 times 1 is what? That is 5. We're kind of building our numerator right here. All right, so now you're going to go this way. 2 times 3, that's 6. And because this is an addition problem, we're going to put a plus right there. So this little crisscross pattern right here is building our numerator. And we're going to put this over the denominator, which is going to be this number times this number, 2 times 5. That is 10. So our final answer here is 11 over 10. Okay. Now, this is a beautiful way of adding fractions, and it's an absolute must-know math tactic. Okay, probably one of the most I mean, if I had to kind of think about some of the most valuable tools in my math toolkit, it would be this right here, and this comes in extremely handy in algebra. But that doesn't mean that you don't have to know the LCD. And there's some other issues with this bow tie method. Sometimes you can end up with a denominator that's not the lowest common denominator, hence you'd have to reduce or simplify your final answer. But I wanted to just be fair about this problem and state, hey, I told you that you could do this problem here using a bow tie method, but you would have to do a little bit of cleanup afterwards, okay? So I just wanted to be honest with you and say, yeah, look here, here's the method, but don't run away. But like, good, I never have to do the LCD ever again. Not true at all. And you must know how to find the LCD, especially in algebra, okay? So let's go ahead and get this kind of squared away once and for all. And so that way we have no more questions about the lowest common denominator, what it is, or how to find it. Okay, so just a quick review. When we want to add or subtract fractions, the denominators must be the same. So for example, if I have 1/5 plus 2/5, I can add these fractions because the denominators are the same value. It's 5, right? So all we do here is simply add the respective numerators. In this case, it's 1 and 2. So 1 plus 2 is 3. So our final answer is 3/5. Okay, no problem here, but look right here in this problem, we don't have the same denominators. So what do we need to do? We need to find the LCD, okay? So let's go ahead and talk about how to find the LCD. And we're not going to start off with this. I'm going to do this problem in just one second, but let's do something a little bit easier. Now, I did indicate that some of you are saying, listen, Mr. YouTube Math Man, I am a certified professional expert in the LCD. Give me a practice problem. Well, here you go. 1/5 plus 2/3. So if I asked you, what is the LCD? A lot of you would say, well, that's 15. Okay, so give me my A plus and my happy face. All right, well, there you go. Here's your happy face and your A plus. Nice job. Okay, now, what is the LCD? Okay, well, most of you, and there's nothing wrong about what I'm saying here as well. So if you're thinking in these terms, that's very good. But we do have to kind of take it a step further. But let's start with something easy. So the LCD, a lot of ways students think about it, it's the lowest number that both these numbers can divide into without a remainder. Okay, so 15, 5 goes into 15 without a remainder, and 3 goes into 15 without a remainder. Now, let's take a look at another number they both go into. Well, 5 goes into 30 without a remainder, and 3 goes into 30 without a remainder, but it's not the lowest number. Okay, 15 is the lowest number, so that would make it the lowest common denominator. So that's kind of the typical way that we think about the LCD. And I can remember doing this stuff way back in the good old 1970s. That was such an awesome time to go to school and, just kind of doing basic fraction problems, arithmetic. And I don't even know how I got the LCD because I was thinking of it in this terms, okay? Now, this is pretty easy. You're like, yeah, this is easy stuff, Mr. YouTube Math Man. Well, let's just change these denominators. What if I gave you this problem? 568, 1 over 568 plus 2 over, I don't know, 3, let's say 309, something crazy like that. Well, if I gave you this problem, most of you would be like, forget this. I'm not doing this anymore. And then you would just like leave the video, right? Well, I don't want you to do that because these denominators are much more challenging. This is a lot more work. Okay. Yeah, and indeed, this is why, dealing with fractions oftentimes makes people look like that. Okay, so no need to get distressed. I'm going to teach you exactly what you need to do. I'm not saying there's not work involved, but at least you'll have a direct procedure on getting the LCD. Okay, so let's go ahead and get into this right now. But before I show you that, let's finish this process up. So I did indicate that to do this problem here, the LCD is 15. So that means that we have to convert each of these or rewrite these fractions such that the denominator is the LCD. And of course, that would be 15, right? So we have to change both denominators to 15. So we have to take 1/5 and change this 5 into a 15. So how can I change this 5 into 15? Easy, just multiply it by 3 because 3 times 5 is 15. But if I multiply the denominator by 3, I have to multiply the numerator by 3. So this fraction now becomes 3 over 15. Okay, so here's 2/3. How do I change a 3 into 15? Easy, multiply it by 5. That becomes 15, but I have to now also multiply the numerator by 5, so that becomes 10 over 15. So here is my new fraction, okay? These fractions here, just to be clear, are the same, okay? These are the same fractions. This and this, they're equivalent to one another. Matter of fact, if I said, hey, reduce 10 over 15, you would get back to 2/3. Okay, but we rewrote these fractions such that they have the lowest common denominator, and now that will allow us to add the fractions, okay, because now they have the same denominator. So just put that one denominator and add the respective numerators right here, and I'll get the final answer of 13 over 15. Okay, so this is what we need to do to add or subtract fractions that do not have the same denominators, right? But it all started with finding the LCD. Okay, so I'm going to show you now how to find the LCD, but before I show you that, I would like to, have you pay or go to that subscribe button, look at that subscribe button, and just think to yourself, hey, am I learning anything with this particular video? If you even learned a tiny little bit, just hit that subscribe button and that notification bell. That really does help me tremendously. Okay, that little tiny act, it really kind of gives me the fuel to keep going on YouTube. I just love teaching math, but every time someone subscribes to my channel, I kind of feel like I've gained a new student. And on my channel, you'll find 2,000 plus videos from basic to advanced math, like basic math to advanced math, like calculus and everything in between. So please take advantage of all this content if you are, learning mathematics. If you want my best math instruction, just follow the links in the description below, and you can check that out. But anyways, back to the problem. Okay, so here we have 3 over 20 plus 1 over 8. Now, I want to just kind of highlight something stylistically here. Notice how in these fractions here, I'm writing the problem with angled fraction bars. There's not a problem to do this. If you like to write your fractions this way, that's perfectly fine. However, I'm going to encourage you to write your fractions with a horizontal fraction bar. Okay, it's a little bit better approach in my experience, especially as you kind of maybe move into algebra. So I'm going to encourage you to use horizontal fraction bars instead of angled fraction bars. Right, this is really, really important, especially in algebra. Okay, so we're going to think of these as we're going to think of the problem as 3 over 20 plus 1 over 8 this way. And you can see here, I'm looking at the denominators. I got 20 and I have 8. They are definitely not the same. So that tells me I'm going to have to go find the lowest common denominator. So 20 and 8. Some of you might be saying, well, okay, I can kind of think about this. I'm like, all right, let me see here. I got to think about the lowest number that both 20 and 8 go into. And a lot of you are going to be able to figure this out. Okay, that's great. If you come up with that number, that's excellent. But what we want to do, and I'm using denominators are pretty reasonable to work with to kind of teach you the procedure so you can handle this problem using this procedure if the denominators we're dealing with were like 208 and 865. Okay, of course, we're not doing this problem. We're doing this problem, but I'm going to teach you the procedure to find the lowest common denominator. Okay, and if you can remember this, this is going to pay off not only in arithmetic, but in algebra as well. Okay, so what we need to do is hone in on each of the denominators, 20 and 8, and we need to prime factor each of these numbers, okay, 20 and 8. And if you never prime factor a number, you can use a simple factor tree like this. Let's focus our attention over here on this 20, then we'll circle back to this 8. So basically, you're going to be factoring this number. Okay, so 20, just think of two numbers that multiply, or the products are 20. So it could be 2 times 10 or 4 times 5. The idea is when you have these two factors like this right here, and always use 2. And we're always kind of making branches here. So we have 4 times 5. What you want to do is look at these numbers and you want to circle any prime factors. In other words, 4 is not a prime number, but 5 is, so let's circle it. Okay, we cannot factor this number anymore because it's prime. But we can factor 4, so 4 is the same thing as 2 times 2, and these 2's here are prime, So what we're going to do is think of 20 as being equal to the product of 2 times 2, and we want to express any multiple, if we have the same factor showing up more than once, express that as a power. So 2 times 2, we'll express that as 2 squared times 5. Right, so 20, its prime factors are 2 squared times 5. Okay, so this is the procedure to find the LCD. And you should practice it with these easy problems so you can do these more challenging problems. Okay, so now let's go up to 8 and prime factor it. So we have 4 times 2. 2 is a prime factor, so we can continue to factor 4. So 4 factors into 2 times 2. So 8 is 2 times 2 times 2. Of course, that is the same thing as 2 cubed. Okay, so now that you have each of your denominators prime factored, and by the way, you could have multiple denominators, more than 2. So you'll have to do this. And let me just kind of reiterate something that I said earlier. I didn't say this wasn't going to require work. Okay. In other words, yeah, you're doing work here, prime factoring, to find the LCD. It's not easy, but it's a procedure that you have to just kind of follow. Okay. But if you know how to prime factor, you should be good to go. Okay, so now that we have the denominators prime factor, what is the lowest common denominator? How do we find it? Okay, well, we can now find the lowest common denominator by representing or basically creating a product where we're going to take each unique prime factor. Okay, out of all the prime factors, what are the prime factors that we got between both numbers? We got these ones right here and this one right here. So the LCD is going to be the product of those respective prime factors. So in other words, we have to kind of scan through and have every unique number, every unique prime factor represented in this product. So here we have 2 squared and 2 cubed. Let's start with the hard part. Now, should we write 2 squared and then represent also a 2 cubed? No, we don't have to do that. So if we have 2 to one power and 2 to another power, so what do we do here when you have the same number to different powers? You always take the highest power. Okay, so we're going to have 2 cubed. Now that situation won't always happen, but when it does, you always take the highest power of this number. So we have 2 and 5 as our factors. This is 2 squared, 2 cubed. You take the highest power, and of course we need a 5 represented as well. Okay, so what's 2 cubed? Well, that's 2 times 2 times 2, which of course is 8, and 5 is 5. So 8 times 5 is what? 40. Okay, so 40 is the lowest number that both 20 and 8 go into. And a lot of you, probably got this right. You're like, hey, Mr. YouTube Math Man, you just wasted my time. I knew it was 40. What are you doing? Listen, again, that's great. But, I'm telling you right now, your brain is not going to work so well in terms of just kind of figuring this out if these are the numbers, we're trying to deal with. Okay, if you got these two fractions, it's going to be much more difficult. You need to understand the procedure here. And this procedure is the same procedure we use in algebra when the denominators are variable expressions. Okay, so now that we know that the LCD is 40, what we need to do is go back to our problem and say, okay, we got the LCD, it's 40. We need to rewrite each of these fractions such that the denominator is 40. So we're going to have to basically, do a little bit of work here to convert or rewrite, again, 3 over 20 into a fraction where 40 is the denominator and 1 over 8 where 40 is the denominator. And of course, to do that is not that difficult per our previous example. Okay, so let's go ahead and do this now. So to fix this 20 where it's a 40, that's pretty easy. All I have to do is multiply it by 2, but if I multiply the denominator by 2, I also have to multiply the numerator by 2, so I'm going to get 6 over 40. And then over here, I have an 8. Well, I got to turn that into 40, so 5 times 8 will do that. So I also got to multiply 5 by the numerator. So here is our two fractions, 6 over 40 plus 5 over 40. Okay, again, they're equivalent to these fractions here, but the benefit or the main idea is instead of these denominators, we both have a common denominator. Okay, well, we have common denominators amongst these form the lowest common denominator, in fact. And now we are ready to go ahead and finish the problem. Okay, so 6 over 40 plus 5 over 40, pretty easy. You have the same denominator, simply going to add the numerators, 6 and 5, so we get 11 over 40. Okay, so you could use the bow tie method here. But if you did that, you would end up with a fraction that is not, where you will not have the LCD. Okay. So what you'll have to do in that case is just reduce that fraction and simplify that fraction. But again, all these things, all these techniques, you need to know there's nothing here that I stated, whether it be the bow tie method or, factoring, prime factors, the procedure, how to find the LCD, etc. Even just conceptually knowing that, hey, what is the LCD? It is the lowest number that both of these denominators can go into. Math is a kind of continual process. Right? There's a lot to learn. So, you can't look at, a simple fraction problem and be like, oh, yeah, this is easy. That's like baby math. This is like one, two, three. Give me the good stuff. Give me the algebra, the calculus, whatever. Listen, make sure you master the foundations, the fundamentals, because if you don't get this down, you're going to have a difficult time later on with that other stuff. Okay, couple of suggestions here. One, if you want to work on fractions, basic math, you must check out my mini course. That's kind of, I think of it like my math boot camp, if you will, for basic mathematics. It's called my Math Foundations course. You'll find a link to that in the description of this video. But also, I have a ton of additional videos on fractions on my YouTube channel that can help you out as well. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.